Alrighty, let's take off. Number 1. The wall behind the wall. You have been told the oldest light in the universe is the edge of sight. It isn't. There is something older out there, sitting further away than that light, in a shell of space you will never photograph. And roughly 22 million pieces of it are inside your body right now, passing through your chest, your hands, the backs of your eyes, without touching a single atom you are made of. Here is what happened. For the first 380,000 years, the universe was too hot and too crowded for light to travel. Photons bounced off free electrons like a ball in a room full of walls. When things finally cooled enough for atoms to form, that light was released all at once, and it's still arriving. That's the microwave background. That's the wall everyone calls the edge. But neutrinos got out first. Not first by a little. They stopped interacting with everything else when the universe was 1 second old. 1 second. They have been flying, unbothered, ever since. And because they left earlier, the shell they come from sits further out than the light shell. About 200 megaparsecs further out. There is a deeper layer of the past out there, and it is not made of light. They're everywhere. 339 of them in every cubic centimeter of space, including the cubic centimeters currently occupied by you. They have cooled to 1.95 degrees above absolute zero. They carry almost no energy. They only feel the weak force, and that combination makes them almost perfectly ignorable. Physicists at Gran Sasso are trying to catch some anyway, with a target made of tritium, hunting for a bump in a graph that would mean a relic from the first second finally hit something. Nobody has caught one, not one ever, out of the 22 million currently inside you. To reliably stop a neutrino from the first second, you would need a wall of solid lead about a light year thick, and even then, you would be getting lucky. We know they're there anyway, because they left fingerprints on the sound waves rolling through the early universe. And in 2015, a team pulled that fingerprint out of the data at 4.5 sigma. We have detected the shape of the hole they left, not the thing itself. And there is a layer under that one. Gravitational waves from inflation would show you the universe at a trillionth of a trillionth of a trillionth of a second old. We haven't found those either, which means the edge you're looking at has at least 2 more edges hiding behind it. Number 2, where the rest of it went. Something has to explain why there's anything past the edge in the first place, and the answer isn't exotic. The answer is that the rest of the universe was here, in the same event, in the same expansion, and it got thrown so far so fast that light has never caught up. Run the numbers backwards without inflation, and the universe doesn't work. Look left, look right, opposite sides of the sky, and the temperature matches to 1 part in 100,000. Those 2 regions have never been in contact. Light hasn't had time to cross between them. There is no reason for them to agree about anything, and they agree about everything. Put a number on how badly it fails. Wind the standard expansion backwards, and the largest patch that could have talked to itself by the time that light was released comes out to about 1 billion light-years across. The uniformity you actually measure runs across 47 billion. You are off by 4 orders of magnitude, which in cosmology is not a rounding error, it's a confession. So in 1981, Alan Guth published the fix. Alexei Starobinsky had already built something like it the year before, and Andrei Linde patched the hole in Guth's version a year later. For a sliver of time, somewhere around a trillionth of a trillionth of a trillionth of a second, space didn't expand. Space detonated. At minimum, 60 doublings. A linear stretch of about 100 trillion. Take one tiny patch that was in contact with itself, that had time to even out, that agreed with itself about temperature. Blow it up by that factor. Everything you can see tonight came out of it, and so did an enormous amount of everything you can't. That's the part worth sitting with. Past the edge is not another universe. It's not a different set of laws or a hole in the map. It's the same explosion, the same stuff, made of the same hydrogen, following the same rules, and the only thing separating you from it is that the light hasn't arrived, and now never will. Guth put it best himself. Inflation takes the problem of explaining 10 to the 90th particles and turns it into the problem of explaining 60 doublings. That's the whole trick. A small exponent doing monstrous work, once, at the beginning, and never again. You will hear that inflation took something smaller than a proton and grew it to the size of a grapefruit. That's a picture, not a measurement, and it only describes the fragment that became your observable universe. The rest of the grapefruit kept going. It's still going. Right now, out past the last thing your telescopes can resolve, is more of the same, ordinary and unremarkable, and completely unreachable. Not hidden, just late. Number 3, how much more there is. You want a number. Fine. Here's the smallest number the evidence allows, and it's obscene. Start with shape. If space were curved, the geometry of the microwave background would give it away, because the hot and cold patches on that map are a known physical size, and a curved universe would magnify or shrink them. Planck measured it. Space is flat to within about 1/5 of 1%. As far as anyone can tell, parallel lines out there stay parallel forever. Now, flat is a limit, and limits have error bars, and error bars can be turned into a minimum size. In 2011, a team did exactly that, carefully, averaging over the models instead of assuming the answer, and got a floor, not an estimate. A floor. The whole universe contains at least 251 volumes, the size of your entire observable universe, at 99% confidence. Picture what that means. Everything you have ever seen, or measured, or named, every galaxy in every deep field image, 2 trillion of them, all of the light that has reached this planet since the planet existed, all of it fits in one bubble. And there are at least 250 of those bubbles. That's the low end. That's the version where the universe is being shy. And notice what that floor is built out of. It isn't a guess about what's beyond the curtain. It's a measurement of the curtain's shape, taken from inside the room. Curvature is the one property of the whole universe that leaks into the part you can see, because a curved space bends the paths of ancient photons and changes the apparent size of the patches on that microwave map. They come out the right size, so space is flat, or so close to flat that any curve has to be gentler than a circle 250 billion light years across. And if space is exactly flat, and if it doesn't fold back on itself, then the answer isn't 251. The answer is infinite. Not infinite as a figure of speech. Infinite as a prediction that falls out of a measurement, with matter in every direction, forever, past every horizon anyone will ever have. Hold both of those in your head at once. The floor is 251. The ceiling might not exist. That is the actual state of human knowledge about the size of the thing you live in, and the gap between those two answers is the largest open question anybody has ever failed to close. There's one escape hatch, and it's a strange one. Flat doesn't have to mean endless. Space could be flat and still wrap around, like the screen of an old arcade game where you fly off the right edge and reappear on the left. We can't tell. Nobody has found the seam. Number 4. The light that's running away from you. Some of the light hitting telescopes tonight spent billions of years going the wrong way. It left a galaxy, aimed straight at where the Earth would eventually be, and for the first few billion years of its trip, it got further from us every single day. This is where most people's mental model breaks. There's a distance where space is expanding away from you, faster than light travels through it. It's called the Hubble sphere, and the intuition is that anything past it is invisible, because the photons can never fight the current. That intuition is wrong, and it's wrong in a beautiful way. The photon is doing its best, moving at light speed through the space in front of it, but the space between you and the photon stretches faster, so the gap grows. It's losing. It's going backwards. It can do that for 4 billion years. But the current slows. The Hubble sphere isn't fixed. It grows, and eventually it swells out past the struggling photon and swallows it. Now, the same photon, doing exactly what it was always doing, starts closing the distance. Billions of years later, it lands on a mirror in orbit and becomes a data point. And that photon crossing the Hubble sphere is the reason people get this wrong. There are 3 different boundaries out there, and only 2 of them are real. The Hubble sphere is where the recession hits light speed, and it is not a horizon at all. It's a speed limit sign you can see straight past. The particle horizon is how far light has actually traveled since the beginning, and that's your observable universe. The event horizon is how far anything you send from here can ever get. Confuse the first with the other 2, and the universe stops making sense, which means the majority of galaxies you have ever seen an image of were receding faster than light when they sent it. Past a redshift of about 1.5, all of them were. That's not an exotic subset. That's most of the catalog. The record holder is a galaxy called MOMZ-14. Its light left when the universe was 2% of its current age and took 13.5 billion years to get here. In that time, the galaxy kept moving. It now sits about 34 billion light-years away, which is more than twice as far as the light traveled. The galaxy in that image is 500 light-years across and holds about 100 million stars. And everything you can say about it is 13.5 billion years out of date. Whatever it turned into, whatever ate it or merged with it, happened in a place that has been moving away from this one the entire time. The finish line ran away during the race, and the runner still arrived. Number 5. Nothing ever leaves. It just freezes. Right now, as you watch this, galaxies are crossing out of your reach forever. Not out of sight. Out of reach. And here's the horrible detail nobody warns you about. You don't get to watch them go. They don't blink out. They stall. There's a boundary around you, somewhere between 16 and 18 billion light years out. And it's a different animal from the edge of what you can see. It's the limit of what you could ever affect or ever be affected by again. Fire a beam of light at anything past it, and the beam never arrives. Not slowly. Never. Dark energy keeps stretching the road faster than the light can walk it. Anything you can currently see past a redshift of about 1.9 is already on the far side of that line. One estimate that gets quoted a lot puts it this way. Roughly 94% of the galaxies in your night sky are already unreachable. You could leave tonight at the speed of light and you would never touch them. Now, the part that gets under your skin. When a galaxy crosses that line, its light doesn't stop. Every photon already in flight still arrives. But each one arrives a little later than it should, a little redder, a little dimmer. The image slows down. Colors drain from blue to orange to infrared to radio to nothing at all. The last picture stretches out over billions of years and never quite finishes. It's the same thing that happens to something falling into a black hole. You never see it cross. You just watch it fade in place, frozen forever, while the object itself has long since gone somewhere you can't follow. And this is running right now, on a schedule. By one estimate, every year, about 160 billion stars worth of galaxy, roughly one Milky Way, slips past the line and becomes permanently untouchable. Not next century. This year, there are galaxies in tonight's sky that were still theoretically reachable when you were born, and are not reachable now, and nothing about their appearance has changed to tell you which ones. Scale that up. In about 100 billion years, every galaxy outside the local group will have faded off the map. Whoever is left will look up at a small, still, empty sky and correctly conclude, from the evidence available to them, that the universe is static, eternal, and consists of exactly one galaxy. They will be wrong, and there will be nothing in their sky to tell them. Number 6. The threads. Up to now, every single thing in this video has been measured. Funded, published, argued over, but measured. From here on, we're into things physics insists should exist, and that nobody has ever found. And with the first one, the failure to find it is the interesting part. When the universe cooled, it went through phase changes, the way water becomes ice. Freeze a pond, and the ice doesn't form as one perfect sheet. It forms in patches that start independently, each one picking its own alignment. And where those patches meet, you get cracks that can never be smoothed out. Now do that to space itself, at a moment when the universe was expanding so fast that neighboring regions couldn't send each other a message. Each region picks its own vacuum. Where the choices don't match, the mismatch gets locked in. Tom Kibble worked this out in 1976, and the result is a cosmic string. Try to hold this object in your head. It's about 1,000,000 times thinner than a proton, so thin it has no meaningful width at all, and it weighs 10 million billion tons per centimeter. A single kilometer of this thread outweighs the Earth. It whips through space at nearly light speed, under a tension you could not describe with any material you have ever touched. It also breaks geometry. Space around a cosmic string isn't bent, it's missing. A wedge has been cut out and the edges glued together, like a paper cone. Fly past one and you feel nothing. Look past one and you see the same galaxy twice. Two identical copies, side by side, not smeared or warped the way a normal gravitational lens smears things. Just duplicated. In 2003, astronomers found exactly that. Two identical objects, same redshift, same shape. They named it CSL1, and the field held its breath for 3 years, until Hubble looked closely in 2006 and found two ordinary galaxies in the middle of a collision. Nothing else has ever turned up. Planck went looking in the microwave background and found no scars, which killed the heavyweight version outright. Pulsar arrays picked up a low hum across the galaxy in 2023 that could be strings, if the strings are far lighter than anyone expected, and could equally be black holes circling each other. Nobody can tell yet. The same freezing process should also have made sheets, and monopoles. And if the sheets exist, even one of them stretched across your sky would dominate the entire energy budget of the universe and wreck the expansion. It doesn't. So either those things never formed, or inflation swept them so far out they took the evidence with them, which leaves two options, and one of them is that they are all somewhere else. Number 7. The place where the constants drift. Every question so far has been about what's out there. This one is about whether the rules are. There's a number that controls how strongly light and matter grip each other. It's about 1/137, and it decides the size of atoms, the color of every flame, the spacing of every line in every spectrum you have ever seen. Change it, and chemistry changes shape. You can measure it at a distance. Light from a quasar passes through gas clouds on the way here. Those clouds absorb specific wavelengths, and the pattern of what's missing tells you what that number was, out there, billions of years ago. John Webb and his collaborators did this for hundreds of systems, using telescopes in Hawaii and in Chile. They got something nobody ordered. The northern sky said the number was slightly smaller. The southern sky said slightly larger. Not a change over time. A change with direction. A dipole, 1 part in 100,000, pointing somewhere in the southern sky, holding at around 4 sigma. In 2020, they pushed the measurement out to a quasar 13 billion light-years away, and the pattern held. Now the honest part. Other teams think this is an instrument problem. Line up your wavelengths slightly wrong, and you can manufacture this signal out of nothing. So, They built a spectrograph calibrated against a laser frequency comb, pointed it at the brightest suitable quasar in the sky, and measured with about 10 times the precision. They got 0. No variation. The most precise measurements anyone has ever made land exactly on the value in your physics textbook. There's a strange piece of evidence sitting in a uranium mine in Gabon. 2 billion years ago, the ore there was rich enough and wet enough to start a nuclear chain reaction on its own, and it ran underground for a few 100,000 years. The waste products it left behind are exquisitely sensitive to that number, and they say it has not moved here on this rock in 2 billion years, which constrains exactly one location in the universe, this one. So it's unresolved, and the reason to care is what happens if the drifting version is right. There's a resonance in the carbon nucleus that lets stars stitch helium into carbon. It's a knife edge. Nudge the constants, and stars stop producing carbon in any useful amount, which means one direction in the sky might be running slightly different chemistry. And far enough out, past everything you can see, there could be entire regions where carbon never happens. Stars burn wrong, and nothing that could ask a question ever gets built. Number 8. The ripples that were bigger than the universe. The galaxy you live in was seeded by a wave that was once larger than everything you can see. Not larger than the galaxy. Larger than the observable universe. During inflation, tiny quantum fluctuations were stretched along with space. A ripple that started smaller than an atom got dragged out to enormous size, and at some point its wavelength became bigger than the distance any signal could cross. When that happens, the ripple stops evolving. Nothing can act on it. Physics can't reach across it to smooth it out. It just freezes at whatever amplitude it had, and it waits. Then inflation ends, expansion slows down, and the reachable distance starts catching up. One by one, the frozen ripples come back inside, and the instant they do, gravity gets hold of them. The dense parts pull in more. The empty parts empty out. Every filament of the cosmic web, every cluster, every galaxy including yours, grew in the trough or the crest of a wave that had been sitting outside the horizon, doing nothing for an unimaginably long time. There's a detail here that sounds like bookkeeping and isn't. Those ripples were not all the same strength. Inflation left slightly more power in the big ones than the small ones, and the measured tilt is 0.965 instead of a clean one. That tiny shortfall is one of the most valuable numbers in physics, because it's exactly what you get if the field driving inflation was rolling gently downhill rather than sitting still. The lopsidedness of the ripples is the fingerprint of the thing that made them. You can see the proof. The biggest patches on the microwave sky are too large to have been processed by anything. They're raw. They are the primordial pattern, unedited, and the fact that the temperature ripples across the sky are all in step with each other is the giveaway. Waves that started at random times would arrive out of phase and blur into mush. These are coherent. They were all set going at the same instant, before anything could talk to anything else. Now the part that should bother you. Inflation didn't stop making ripples at the exact size of what you can see. There are modes out there right now, larger than your entire horizon, frozen, untouched, still waiting, and the reachable distance is still growing. So they're coming back in, slowly, one at a time, over billions of years. The outside is delivering the pattern for what the inside is going to look like next, and there is no way to read it early. You cannot see the wave until it has already started building something. Structure from beyond the edge is arriving, not objects. Instructions. Number 9. The edge has a temperature. You've been picturing the edge as a nothing, a limit, a place where the data runs out. It isn't. It's a surface. It has a temperature, and by one accounting, it's the single most significant object in the universe. In 1977, Gibbons and Hawking worked out what happens to a horizon in an accelerating universe, and the answer was that it behaves exactly like the surface of a black hole. Same mathematics. It has an area. That area carries entropy, and it glows, faintly, with real thermal radiation at a temperature of about a billionth of a billionth of a billionth of a degree above absolute zero. That's 30 orders of magnitude colder than the microwave background. Colder than anything anyone has produced in a laboratory. And it's not a metaphor. The boundary of your observable universe is a warm object, in the same sense that a black hole is a warm object, radiating into a cavity that contains everything you have ever known. Then it gets worse. Two cosmologists added up the entropy of the universe, everything in it, and the ranking is not close. All the stars together come to 10 to the 80th. All the light from the Big Bang, 10 to the 89th. Every stellar black hole, 10 to the 97th. All the supermassive black holes at the hearts of all the galaxies. The biggest reservoirs of disorder inside the horizon come to about 3 times 10 to the 104th. The horizon itself is 2.6 times 10 to the 122nd. The empty boundary outscores the entire contents by a factor of about a quadrillion. Everything inside, all of it, is a rounding error against the surface that surrounds it. And that isn't a coincidence. It's a rule. The maximum amount of information you can pack into any region of space doesn't scale with the volume, which is what your instincts insist. It scales with the area of the surface around it. 1 bit for every Planck square, and a Planck square is a millionth of a billionth 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 of a centimeter on a side. Try to exceed that limit, and you can break the second law of thermodynamics, which nature apparently refuses to allow. So the boundary has room to encode absolutely everything happening inside it. Every star, every conversation, every thought you have had, described on a surface you will never touch. Gibbons and Hawking added one more thing in that same paper, almost as a shrug. Because different observers have different horizons, they have different temperatures, and they disagree about what counts as a particle. The nothing at the edge weighs more, informationally, than the something. Number 10. Everyone gets their own edge. Get in a ship. Fly 46 billion light years, straight out, all the way to the edge you have been hearing about for the last half hour. Arrive. Look around. Nothing. No wall, no fog bank, no shimmer, no sign. Ordinary galaxies, ordinary stars, an ordinary sky, and an edge exactly 46 billion light years away, in every direction, including the direction you came from. It moved with you. It was never a place. It was a statement about how long light has had to travel to wherever you happen to be standing. That's the real answer to the question in the title. There's no boundary out there. Every galaxy sits at the center of its own sphere, and the galaxy at the edge of yours can see an entire half of the universe you will never have access to, and its neighbor can see further still, and that chain runs outward with no center, no rim, and no end. Work out what that costs you. That galaxy sees a full half of a universe that is closed to you permanently, and its light is the only report you will ever get from it, and the report contains nothing about the half you're missing. Go one step further out, to a galaxy on their horizon, and the fraction you share drops again. The chain of overlapping spheres runs outward for as long as there is anything out there to run through, and every link is a witness to something you can't reach. Which means everything in this video, all of it, rests on one assumption. That we are not special. That our patch is a fair sample. Measure far enough, and the lumpiness does smooth out, at around 300 million light years. And that's the evidence the assumption stands on. And it is real evidence. More than 1 million galaxies were counted and mapped to find that number. And below 300 million light years, the universe is all lumps and voids and structure. And above it, the lumpiness genuinely does average out into something boring and even. Boring is what you want. Boring is what lets you say anything at all about a place you will never see. Except, there's a crack in it. Count quasars across the sky, and they aren't evenly spread. There's a direction. Our motion should explain some of that lopsidedness. And it explains maybe a third of it. The rest shouldn't be there. Independent catalogs keep finding the same thing, past 5 sigma now, and nobody can say yet whether it's a flaw in the surveys or a flaw in the assumption. Because if we are special, if our patch isn't typical, then every confident sentence about what lies past the edge collapses at once. You can't see past your horizon. You never could. The only reason anyone believes there's anything out there at all is the assumption that this spot is nothing special. And right now, there's one measurement quietly arguing that it might be.